A good evening to you, wherever you are, and welcome to our today's class. Hoping that you are doing well. And I have a question here that I have been able to get to my desk, forwarded to me by my student. And the question is a flow chart that was provided to the students' table to be able to provide an answer in terms of what was asked under that flowchart in their Cat 1 examination when they came back to school. So I'm going to draw the flowchart and be able to proceed with the explanation in terms of giving the answers to the questions given below. So this is what they were given. So we had black solid. So we begin with this, the blue solid. And from here, there's an arrow that proceeds forward, and this branches into two parts. So we have this part that is given as now the black solid. So this is the black solid. And at the bottom here, we have a brown gas. And this other part has this other chamber that has, so let me just extend this part at this other end for the purpose of making everything very clear to you. So we have this, and this has solution K, correct, of pH 4. Solution K of pH 4 to mean this solution is weakly acidic. So whenever you get a question of this type, you are first supposed to take yourself through the whole flow chart, and this is just a way in which examiners would want to test you on the level of your understanding of either a particular topic or quite a good number of topics, all incorporated in this flowchart. Having a look at this, you realize that there are some areas you can be able to use to be able to come up with some very crucial information that can help you understand what the examiner was all asking about. So whenever I see a blue solid, I need to ask myself, which examples of compounds or chemicals are basically blue in color in as far as chemistry is concerned? And which black solids and which brown gas can all get put together for us to get a black oriented appearance with the blue majorly appearing in that mixture. So whenever someone picks a black solid and again picks a brown gas and they end up giving a blue solid, then whatever comes into your mind is this. In most chem compounds, whatever has to give us a blue appearance when it is in a solid form is copper. Copper is a transition metal. This metal has an atomic mass 63.5 or 64 grams per mole. And this compound majorly will appear blue if it has to end up having a nitrate part as a radical. And we say a radical is a group of compounds. Now look at this. We first say, from our understanding, that when someone talks about a blue appearance in terms of a solid, then copper as a metal must be present, which is a transition metal found between group 2 and group 3 elements in the periodic table, which is a grade that houses the elements discussed in chemistry. And this copper has an atomic mass 64 grams per mole or 63.5 grams per mole. So, but now we need to know if this is the metallic part, the cation part, the metallic part or the cation part. So copper 2 ions are always associated with a blue appearance. There's a color. When you are doing the testing of the cations present in a compound, you normally use sodium hydroxide or caustic soda, or you normally use ammonia solution or ammonium hydroxide. When a particular compound in solution form or in an aqueous state has copper ions and sodium hydroxide is added, or caustic soda is added, or ammonia solution is added, or ammonium hydroxide is used, then you expect to have a pale blue appearance or a pale blue precipitate getting formed. Now, in most cases, ammonia solution is used. When few drops of ammonia solution are added to a compound containing copper ions, a pale blue precipitate appears. But when ammonia solution is added in excess to the solution containing the copper ions, a deep blue precipitate is formed. To mean copper ions are actually soluble in excess ammonia solution. But now, it is a solid. It might not be only copper. It must be a cation part and an anion part. We have several anions that are normally discussed in chemistry, which are referred to as radicals, like the nitrate, the carbonate, the sulfate, see, the phosphate. So the issue is, what would be the most possible what? Anion or radical. You see, to be available here and combine the copper to give us a blue solid. Now let's come here. We have a brown gas. A brown gas is obviously nitrogen dioxide or nitrogen 4 oxide. So the IUPAC name of this gas is nitrogen 4 oxide. But it can also be able to get referred to as nitrogen dioxide. Dioxide. So you can talk about nitrogen 4 oxide or nitrogen dioxide. This is the IUPAC name. Okay, so any brown gas you have actually get given should be nitrogen dioxide or nitrogen 4 oxide. So this gas must come from which radical? Nitrate. Yeah. Of course, I can't expect to find NO2 as a gas coming from a sulfate. That does not make sense to get that extent. So this nitrogen 4 oxide or nitrogen dioxide must come from a nitrate. So obviously, this other part must be a nitrate. So that the blue solid is going to be copper, you see, because of the blue appearance, and nitrate coming as a result of the brown gas that gets formed here when this compound undergoes heating. So the compound, which is the blue solid, in this first chamber has undergone heating, and this compound is copper 2 nitrate. Copper because of the blue appearance, and the nitrate because one of the products is a brown gas, which is nitrogen dioxide, having obviously come from a nitrate as a radical, which is very important in the formation of compounds. So the process that this blue solid undergoes is called thermal decomposition. In other words, the compound undergoes decomposition by the use of heat, or you can also say thermal dissociation. Thermal dissociation. So the compound is dissociated or decomposed by the action of heat or heat. And of course, because it is copper, then that means we should be able to have the copper making our compound to be blue, and the nitrate because we are forming a brown gas, which is NO2 or nitrogen 4 oxide, obviously getting obtained in most cases from a nitrate. So the compound becomes copper 2 nitrate. So the copper 2 nitrate as a compound undergoes thermal decomposition or heat. And obviously, we are forming a black solid, which is copper 2 oxide, and a brown gas, which is nitrogen dioxide. And obviously, we must also form a gas called oxygen gas. So the major products getting captured in this flowchart are: one, the black solid, copper 2 oxide, okay, copper oxide, and the brown gas, which is nitrogen 4 oxide. Yeah, the only non-brown gas in chemistry, and the black solid. All solids discussed in chemistry must get associated with colors, and most of them are black. But because of this appearance of this initial compound getting heated, then that must be common to oxide. But other compounds can also be black, and they must also be oxide as well. So if you proceed to this other end, we can actually be able to have water just on this arrow, and that means you have copper 2 nitrate now being our solid, undergoing thermal decomposition to give us copper 2 oxide, our solid, nitrogen 4 oxide, our gas, and oxygen, our gas as well. So we might decide to balance this equation for us to have a clear picture of what we have as our chemical equation in this case. So we want to balance the equation. So we put here 2, then we can put here 4, so that is 6. So 2 copper atoms, you can also put here 2 copper atoms, 4 nitrogen atoms, 4 nitrogen atoms, then you have 6, 12 oxygen atoms. So these are 8, 9, 10, 11, 12. The equation is balanced. So that is thermal decomposition of copper 2 nitrate, which is a blue solid, being able to get placed in our first chamber in this flowchart. So let's look at this. Now what happens when this gas, the brown gas, gets dissolved in water? So we expect to find nitrogen 4 oxide getting dissolved in water, okay, to form products. So let's just put this equation here. So we have nitrogen 4 oxide getting dissolved in water. So this is a gas, this is a liquid, so it forms 2 different types of what? Products. One, it will form nitric 5 acid. This is nitric 5 acid. So whenever nitrogen 4 oxide is dissolved in water, it gives first nitric 5 acid and then also forms nitric 3 acid. So again, nitric 3 acid. So nitric 5 acid and nitric 3 acid. So I can just put here 2 and be able to have the equation get balanced. Yeah. So this aqueous, this also aqueous. But again, because we had oxygen being part of our products here, so that means that oxygen must have mixed with this nitrogen 4 oxide. So this nitric 3 acid can further react with the oxygen forming part of the products on this side after thermal decomposition to give us nitric 5 acid. So that at the end of the day, the nitric 5 acid becomes our product. In this case, so you can just say aqueous, gas, and aqueous. So that can as well become our product on this. So you can just be able to put 2 here, and as well put here 2. Let's see, you can put as well 2 here. So 2 hydrogen atoms, 2 hydrogen atoms, 2 hydrogen atoms, 2 hydrogen atoms. This is 6, this is 46, so that's correct. So the nitric 5 acid becomes weakly acidic with a pH of 4. And of course, we have strong acid like sulfuric 6 acid and hydrochloric acid, which have a pH of 1 or 2, the maximum, to mean they are strong acids. On the other hand, acids can be weakly, and they can be able to possess a charge of 4, 5, 6, up to 6.9. So this is just a brief summary of what you're supposed to read as far as this flowchart is concerned.